On our original log scale, if we were to write a confidence interval, it would look like this. We would say the following quantity is true with probability 95%. We would say that the true difference, the mean log of x minus the mean log of y, is less than some particular upper bound and less than some particular lower bound. And we would calculate these upper and lower bounds the way we always do when thinking of t-tests and the corresponding confidence intervals, just with all our values on the log scale. So this is the upper bound and lower bound that we obtain for the difference in means when everything is in terms of log dollars. So if we obtain this confidence interval, which we believe is an inequality that's true with probability 0.95, now we can write the same thing. We can write the same thing and manipulate the inner part in the same way we did before. So if we substitute the word median for mean, this is going to be approximately the same quantity. If we switch the log and the median, it's going to be the same quantity. So I can now write the log of the median of x minus the log of the median of y. Okay. And now if I want to, I can do the same thing to each part of this inequality. Specifically, I could take e raised to the power of each of the parts of this quantity. And we just showed that if you take e to the log of median x over median y, what you get is the median of x divided by the median of y. But if I also take e to the upper bound and e to the lower bound, then what I've achieved is a new confidence interval with new upper and lower bounds for the ratio of the medians. So remember that this lower bound and this upper bound are just some number. Maybe it was 1 and 9. Okay? Now what I have is some new number, 2.7 to the 1, 2.7. 2.7 to the 9, whatever that is. I have some new upper and lower bound, and my new statement is that the probability that the true ratio of medians falls within those bounds is 0.95. Why? Because I started off with this statement, which was justified since on the log scale everything is approximately normal. The assumptions underlying this confidence interval should be approximately true. Then all I did was manipulate the inequality so that it should still be true with probability 0.95, and I've ended up with a confidence interval for the ratio of medians on the original scale instead of the difference in mean logs. So now if you do your t-test, one of the things you're going to end up with is an estimate of the difference in means on the log scale. And what we've seen now is that if you take e to the power of that difference, you've got an estimate of the ratio of medians on the original scale. And also, if you have upper and lower bounds for a confidence interval on that log scale for the difference in means, if you take e raised to the whatever the upper bound is and e raised to the whatever the lower bound is, now you've got an interval for the ratio of medians. And this statement is as true, the fact that this statement is true with probability 0.95, that's as true as your assumption that it's okay to switch the means and the medians. So this all depends on how well it worked to take the log, but typically taking the log works pretty well. There's one more statement I want to make about this. I'm using the words mean and median here rather than notation like mu and x bar. And I'm doing that on purpose because I want to make it really clear what means and medians are without having to introduce sample and population notation for the medians. But I do want to make sure that you see that sometimes when I'm using this notation, I'm referring to the population, and sometimes I'm referring to the sample. When I write down a statement for my confidence interval, the way to interpret this is the probability that the true population difference in mean logs is between the lower and upper bounds is 0.95. But when I refer to this value d over here, that's just my estimate of the difference in means. So the way I've been using this notation is sloppy in that way on purpose. Sometimes I'm talking about the sample, sometimes I'm talking about the population. This is a statement about how to interpret your estimate of the difference in mean logs. And this is a statement about an interval for the true difference in mean logs.